Let's apply Euclidean algorithm to obtain integers x and y satisfying the following. First question, GCD of 56 and 72 must be equal to 56x plus 72y for some integer x and y. And the second question, GCD of 24 and 138 must be equal to 24x plus 138y for some integer x and y. Now, first question, we need to produce integer x and y such that GCD of 56 and 72 is exactly equal to 56x plus 72y. Okay, now we know that GCD is same as HCF, so GCD of 56, 72 must be equal to highest common factor of 56 and 72. Now there are many methods of finding highest common factor. One of such method is using Euclidean algorithm. Let's apply Euclidean algorithm. Or another method is by using long division method. Let's apply long division method. In that process, what we do is we take the bigger number and divide it by smaller number. 56 times 1 is 56 and the remainder is 6. And whatever remainder we get, we divide the divisor by the remainder. So divisor is 56. We divide the divisor, that's 56, by the remainder, and we continue this process until we get remainder equal to 0. 6 times 9 is 54. The remainder is still not 0. We get the remainder is 2. Again we divide the divisor, which is 6, by 2, and we get the quotient equal to 3 and the remainder is 0. Okay, now we say that HCF equal to 2. HCF equal to 2, or GCD of 56, 72 is exactly equal to 2. Now why does this process work? This process works because of the fact that GCD of A, B is exactly equal to GCD of A, GCD of A, B minus AQ for any integer q. In fact, if I divide b by a and if the quotient is q, then b minus aq is remainder. So GCD of a, remainder is simply equal to GCD of a, b when b is divided by a. So basically we are dividing and saying that remainder, the GCD of the remainder and the number must be same. So we did started with GCD of 56 and 72. Then we say that, well, GCD of 56 and 72 must be equal to GCD of 56, 72 minus 1 times 56. Then we say that, well, that is GCD of 56, 6. 6 is the remainder in this case. Now again we divide 56 by 6 to say that this must be equal to GCD of 56 minus 9 times 6, 6. And 56 minus 9 times 6 is just 2, and that's equal to GCD of 2, 6. We can further divide and say that, well, 2 times 3 is 6, and so that is equal to 2. Now let's do it backward. 2 equal to 56 minus 9 times 6. 56 minus 9 times 6. If we proceed it backward, we can get it in term of 56 and 72. Let's do it. 56 minus 9 times 6 equal to 2. But again 6 equal to 72 minus 1 times 56. So 6 can be written as 72 minus 1 times 56, and then 9 number of 56 and 1 number of 56 gives us 10 number of 56, and then 9 times 72. So we got 2 equal to 56x plus 72y, and we can take x equal to 10, y equal to minus 9. 560 minus 9 times 72 is just equal to 2. Similarly, let's write GCD of 24 and 138 must be equal to 24x plus 138y. Okay, once again we divide 138, the bigger number, by the smaller number 24. You see that 24 times 5 is 120, and when we subtract it we get remainder equal to 18. Now we divide the divisor, that's 24, by 18, and 18 times 1 is 18, and we get the remainder equal to 6. Now we divide the divisor, which is 18, and we get 3 times 6 is 18, and the remainder is 0. Now we can say that GCD of 24, 138 is equal to highest common factor of 24 and 138, and that's equal to 6, which is equal to, you see that 18 minus 24, 24 minus 18. And again 18 equal to 138 minus 5 times 24. So we write 24 minus as it is. Instead of 18 we write it 138 minus 5 times 24. Well, that can be written as plus 5 number of 24 and 1 number of 24, that's 6 number of 24, minus 1 number of 138. So we can choose x equal to 6 and y equal to minus 1. An obvious question is, are these solutions unique? The answer is no. We can simply add and subtract multiple of 24 and 138, or the LCM of 24 and 138 to x and y to get other solution.